Alright, welcome to Homework Takeout, page 287, number 9. We have a question that says, the game of euchre uses only the 9s, 10s, jacks, queens, and kings and aces from a standard deck of cards. How many 5 cards hands have A, B, and C? I'm not going to read A, B, and C yet because there's a lot of restrictions here we have to work with before we can even look at over here. So we have to take a look at the sample space here, or the restrictions. We're not dealing with all 52 cards. We have to figure out how many cards we're actually dealing with. So remember, how many 9s and 10s and jacks, queens, and kings there are? Each rank has 4, right? There's 4 9s, there's 4 10s, there's 4 jacks, 4 queens, and kings, and aces. So how many cards are there in total? 1, 2, 3, 4, 5, 6. So 4 times 6. There are 24 cards in total. So that's what we're working with. Okay, so they want to know how many 5-card hands have all red cards. Okay, so we have red cards here. 5, 1, 2, 3, 4, 5. Going back to this, there's 24 total cards. Remember, half of them are going to be black, and half are going to be white. Are going to be red. So, what we can do here is we have 5 cards here. We're going to choose from 12. Alright, so the answer to this is going to be 12, choose 5. Because we have 12 red cards to choose from, and I'm choosing 5. That's the short answer. The long answer is, we have, for this first card, we have 12. Second card we could get is 11. We have 11 choices. And then the third card we have 10 choices, times 9, times 8. And because it doesn't, if you have a red jack, queen, king, ace, and a 9, that's the same thing as getting a 9, jack, queen, king, ace. As in, what I'm trying to say is that order doesn't matter. Okay, so because they're considered the same hand, we have to eliminate the repetition here. So there's 1, 2, 3, 4, 5 factorial here. 5 factorial repetitions. So we're going to divide them out. So if we do 12, 11 times 10 times 9 times 8 divided by 5 factorial, we get the same answer as this, I believe. So that's going to be 12 permute 5 divided by 5 factorial. So we can double check the answer here. 12, choose 5. It's going to be 792. And really this is the same thing because combination is a special version of the permutation. Divided by 5 factorial is also 792. Okay? So that's how you get all red cards. Let's do part B here. We have at least 2 red cards. So we have, I'm going to set up my 5 cards here. And 2 of them have to be red. So we have 12 red cards to choose from here. And we gotta choose 2. So 12, choose 2. Actually, we should probably do this the indirect method. So let's back up here. What does this mean to have at least 2 red cards? So 2 red cards is the indirect method is all 5 card hands. And if you subtract, so that's one expression that we have to figure out. If you subtract the hands, or a set of 5 cards, set of 5 card hands with 0 red minus 1 set with 1 red. Alright, so all 5 card hands. So if we have 5 cards here, and there's 24 cards in total, to get the number of all 5 card hands is we have 24 cards to choose from, and we choose 5 of them. So 24 choose 5 represents all 5 cards. This set of 5 card hands was 0 red, so we're going to have no red, so all of them have to be black. So for all these cards to be black, it's going to be 12 choose 5, right? Because we have 12 black cards to choose from, and we got to choose 5 of them, so that represents the number of number of possibilities. And set with 1 red hand, so with 1 red, so 1 of them has to be red. We have to choose that first one. So we have, if 1 of them has to be red, how many red cards do we have to choose from? We have 1 of them to be red. So we have 12 choose 1 possibilities here. And then we still have to count the number of ways we can get these ones. So right here, these ones have to be black. So we have 12 choose 1, or 12 just different ways of getting a red card here, and we're going to multiply it by the number of ways we can get 4 cards here from the 12 black cards. And we're going to be choosing 4 to fill in these slots here, so 12 choose 4. So the number of ways of getting 1 red card is 12 choose 1 times 12 choose 4. Alright, so now you subtract these two. Subtract everything and you should be good. So 24 choose 5 minus 12 choose 5 minus 12 times 12 choose 4, and you get 35,772. That should be a 7. Okay, to summarize here, if we count all the number of 5 card hands and we take away the set of hands with 0 red, take away the set with 1 red, you're going to be left with the situations where you have 2 reds, 3 reds, 4 reds, and 5 reds. That's what this formula is. This represents at least 2 red cards. You have 2, 3, 4, and 5 red cards here. That's represented by this expression. Okay. Now part C says at most 2 red cards. To have at most 2 red cards, at most 2 red cards, that's the same thing as saying if you add most 2 red cards, then you can have, they want the number of ways to have 0 red, 1 red, or 2 red, but nothing more. So we need a formula that is 0 red, 1 red, and 2 red. And we already have an expression for 0 red. 0 red is all black. So 12 choose 5. We have 12 black cards, you choose 5 of them. So we got that part down. 1 red, we already have an expression for that. We have 12 choose 1 to get our red card, and then we gotta choose the remaining 4 black cards, so that's 12 of them. And then now we need 2 red cards. So to get 2 red cards, we do 12 choose 2, because there's 12 choose 2 ways of getting 2 red cards, and then we still need to get the black cards. So there's going to be 3 black cards, so 12 choose 3. And if we add them all together, we should get on your calculator 21,252. Okay, hopefully that explains number 9. If that doesn't help, if you want some more better explanation, talk to me in class, and hopefully I can help you out from there.